Hi friends, happy to welcome you back to another weekly edition of Quick Tip video brought to you by dataplatformcentral.com. So in this week we are again going to present before you a Power BI tip which suggests how you can do correlation analysis within Power BI reports. Correlation analysis is one of a popular analysis which can be used when we have a set of observations and you have to draw correlation between them to see how each of those pair of observations are correlated to each other. In such cases, the common way to do this is by creating a correlation matrix. So we have different ways of creating correlation matrix inside Power BI visuals. So this video is on a step-by-step approach on how you can create correlation matrix. There is a custom visual available inside Power BI, or we can even extend Power BI by directly executing Python or R code for creating the correlation matrix. So let's see how we can do that by looking into a sample illustration. For the illustration, let's open a blank Power BI desktop file and I'm going to connect to my local instance. So let's connect to it in import mode, and I'm going to connect to my dev database, which is ABC Bikes Dev, and we have the sales information of bikes inside this database. So I'm going to pull a couple of measures and let's try correlating between these two different measures. So we have the set of tables now, and I'm going to include all the sales related tables and also the production related dimensions, the brand, the category, etc. So once all of this is loaded, let's add some relationships and then let's go ahead and try creating this correlation matrix. So this correlation matrix is provided by means of correlation plot, which is a function which can be called from using Python or using R related visuals. There is also a custom visual which is available inside Power BI that can be used for the purpose. It also uses R code on the background. So let's see how we can do that. So before we start, the first thing is, because we are using R and Python as a part of it, we need to go to options and make sure that we have Python and R installed. So the best thing to check that would be to go to file and go to options. And once you go to the R scripting, you can see that there will be a home directory for the R, which means that R is installed. If it is not installed, you need to click on this how to install R ring, which will give you the details of how you need to install that and what are the other packages to be added, and all the necessary steps are laid down here, how you can add it and enable and things like that. Similarly for the Python, you can come to Python scripting, and there also it should detect a Python home directory. And in addition to Python, we should have also installed some of the standard packages like pandas, numpy, etc. for using this visual, because these packages would be used inside our Python code while we are going to do a correlation plot. So once these steps are done, once it is installed for the Python, you need to go to your installation folder inside your program files. It should be a 64-bit installation. There should not be a, because you need to use 64-bit installation. So go to the program files folder. Inside that you should have a scripts folder under your Python, and there you need to ensure that you have the pandas, and so you can open this folder inside the command prompt, and then you can make use of the pip program, which is available, which is a utility which is available with the latest version of Python. You can use that to install the pandas and numpy packages. So you can just use pip install. So all these details are specified in the official documentation, which says about how you can install Python and R in your system. So before using any visuals which is going to use R code or Python code, you need to make sure that the installation of R and Python is complete, because the visual will be using the Python environment or the R environment to run on the background so as to calculate and finally visualize your data in the required format. So make sure you complete those steps. If you search in Google for running Python scripts and R scripts in Power BI, you'll get two good resources, which is the official documentation where it is clearly suggested the steps involved in installing and setting up Python for your Power BI. You can follow that. See, it clearly says which website you can download, then what all packages you need to install and things like that. And it has given the step-by-step option on how to check whether it is installed correctly. It can even ask you like how to add the visual, and all the details are given. Similarly for the R, you can get running R scripts in Power BI desktop. These things you can search in internet and you will get the official documentation. So once these are all set up, Now the next point for us is to go back to our report and start adding the visuals. So let's first add a Python visual, then let's add an R visual, and then let's try to do this correlation plot in both the cases, and finally we will use the custom visual which is directly available within Power BI to do the same thing. So we are using 3 different ways to do a correlation plot. In all the cases it is using Python or R scripts on the background for performing the correlation plot. So let's go back to our untitled Power BI desktop file which we have already added the model. So the model is now available. Let's go to the modeling tab and we can see that the relationships are already set up because the database already contains the referential integrity. Using that it automatically picks up the relationships. So now that everything is done, let's first go and let's add a Python script. So once you add a Python visual, automatically you will be provided with a pop-up which asks you to enable the script running. Every time you need to open this sheet with Python or R visual, it will ask you for your permission so as to enable the script running. Only after you provide the permission, it can perform the Python or the R script execution that you have written on the background for rendering the visual. So now that you have given the permission, now let's go ahead and add the data types. So if you go to this Python scripts, it will initially provide you with a blank statement because you have not added any fields. So the first step would be to add the fields. So I'm going to add 4 fields. I'm going to add say order ID which will conform to the count of order ID. So we are going to count it. Then I'm going to add the sum of list price, the discount, and then the quantity. And we can just rename it. This will be item count. This will be just, let's name it revenue for the time being. And the other two, let it be discount and quantity itself. So now that you added, if you see, automatically it generated the data set. So you have created a pandas data set, which is why we have to add the pandas library. And now we need to, and it also already dropped a duplicate. So if there is any duplicate, it will automatically eliminate it. Now we need to add our actual Python code for performing the correlation. So here Python code, if you see, we will make use of a function called heat map for the purpose. So let's see how we can use that. So the Python code will look like this. What we are doing is we are importing another library called Seaborn, and of course we are importing the matplotlib as well, and which has that pyplot library within it. So we are using that, and using both of them we are just calling the heat map. So heat map is the function which can be used for doing correlation plotting inside Python, and we are passing this data set. So this data set is what is made up of our various fields which we have added inside, and then we will call the heat map function, and then we will use the annotate equal to true. In case you want to add the annotations, we will add annotated equal to true, and finally we are asking that plot to be displayed. So when we execute this is how you execute your Python script. So once you execute it, the visual will be rendered. So once you execute the Python script as shown in the figure, you will be able to see your visual. So if you want to see it in full screen mode, you can minimize the Python's window and you can see it. As seen, if you see, whichever there is high correlation, you can see a value which is close to 1. The correlation coefficient will be between -1 and 1. So as you see, the negative correlation can also happen. There are cases where it's negatively correlated as well. You can see it in negative values, and wherever you are looking against the same column, it will be 1 always. So it's, if it's list price versus list price, means it's always 1. Similarly, discount versus discount is 1, so that will be the central line. So this is how the correlation plot works in the case of various measures that you are using inside your plot, and in this case you have used a Python related code. So you can just save it as Python just to understand. And now let's see how we can make use of R plot for getting the same thing. So here we were using, if you go to the visual, it was a Python visual, and we were basically using a Python code. We made use of the Seaborn library and also the matplotlib library, and we were using the heat map function. Now let's see how the same thing can be done inside R. So for that we will use an R script. Let's go inside R script, and again let's use the different columns. Let's use it in the same order that we used here. So we have revenue, discount, quantity, and item count. So let's do the same thing. Let's use, first select the visual, and let's use revenue, which is list price, quantity, discount, and item count. And as same as to what we see in the case of Python, here it automatically generated the R code corresponding to that. It created the pandas data set, and now we need to make use of this data set for doing the plotting. So let's see the R code for that. So the R code for that will be very simple. We'll be just calling the library called coreplot, and we have the function coreplot available inside that. Inside that we'll apply core, which is the correlation of the data set, and then we have some parameters. Most of them are explanatory. The explanation is given side by side. You can see it's either shade, the method, how to render it, and then the type, the diagonal, and things like that. So if you execute this, you can again see the same thing. So when you execute the R script, you can see the visual like this. So again, if you minimize this, you can see the visual in full screen mode, and you can see that again the same visual. You can see the values from 1 to -1 and the legend which shows like what type of values. So if you again see the various measures against each other, it will be 1, and for the other cases it will have accordingly values. So it will have the different types of values. Again, you have different properties here which can be changed so as to bring about some changes in this visualization. So if you want to know more about the coreplot, you can look into the articles which says the various definitions. So if you see this method, this is actually the plot method. There are multiple methods in which you can use coreplot. So method allows you, like, it can have a circle, it can have square, it can have ellipse, it can have number, shade, pie, etc. So here we are using, if you see our case, we are using shade. Instead of shading, we can use circle, which is the default as well. So if you use circle, you can see instead of that the different things will be shown as circles rather than as shade. Or if you want to show it as pie, that is also possible. So these different types of values, you can pass it and you can see accordingly. That's also possible. And again, if you want to see the full chart, it will show you full coreplot. If you want to see only a part of it, like upper part, it will show only the upper part, that means the positive ones. Similarly, if you want to see only the negative ones, you can use lower. So these kind of different parameter values can be passed, and accordingly the changes can be seen in your visuals. That's also possible. And if you don't want the diagonal one, you can pass it false. You will not see that diagonal row, which is all ones. So that diagonal one is done. So all these changes can be done here. And then if you want to do some further cosmetic changes, that also can be done. So let's just put it back to how it was. So let's put it circle itself, which is the default, and then let's make this full to see the full chart, and let's make the diagonal as true. This is the default set of values. So once you get this, you can see how it looks like. Now comes the last part. So this, now what we have done here is we have explicitly executed the R script, and then we have shown the graph inside a R visual. Now we are going to directly use the custom visual which is available inside your Power BI. So let's now use the custom visual. For that, just go to the get more visuals option, and once inside, you can search for correlation. You will automatically get the correlation plot. Just select that and you can click on add, and you will get added to your visuals. So once you get this message telling that the import was successful, you can go to a new page and you can click on this visual, and again it will be using R code only on the background, but you don't have to explicitly call it. The code is already executed for you. All you need to do is, like, you can just drag and drop the required things. So let's first add list price, then let's add discount, then quantity, and finally let's add the item ID. As you keep on adding, you can see that it keeps on adding the, so you don't need to do anything here because it's already adding the things for you. The code is already executed by the custom visual. It's the same as what you did in the last case. Only difference is that here you are not executing the R code yourself, but the R code is automatically getting executed on the background. When you call this custom visual, the code will be automatically executed, and it will provide you with the same default options which you did in the previous case. If you compare both of them, you can see that they have the same visualization. So the previously you had to pass all the parameters and you need to call the function yourself. In this case, it was automatically done for you by the visual itself. So these are the three different ways in which you can call coreplot, which will provide the ability to do correlation metrics inside your Power BI visual. And for this, you can use Python or R. It's your choice. But if you want to use this custom visual, which is the easiest way to do it without understanding any intricacies or any complexities about the code involved, then you need to have R function set up prior to executing it, because this is also using R script on the background. So as seen from this illustration, we have different ways to generate correlation plot inside Power BI. The easiest way would be to use the direct custom visual which is available inside Power BI. We could also make use of the generic Python and R visuals and write Python or R code so as to generate the correlation plots. So the correlation plot is one of the most popular ways of drawing correlations between a series of observations or KPIs that we have inside our sample data. A typical scenario where this correlation comes handy is in the case of medical data, where we have so many observations from multiple patients and we just want to draw a correlation between these observations to make sure that which of these observations are closely related to each other and which of them are not. So hope you enjoyed this quick illustration. Feel free to comment as always, and reward for any clarifications. Feel free to subscribe to my channel if you are finding it for the first time, and make sure you click on the bell icon for getting the weekly updates regarding our videos. Meet you all soon with another useful quick tip next week. Till then, bye and thanks for it.